Hi again, class. So mini lecture 2 for AREC 173, the week of October 19th to 23rd, where we're talking about agriculture and sustainability. So I'm going to share my screen with you. And what we're going to, I'm going to entitle this mini lecture Borlaug and Jevons as two important kind of historical personalities that help us think about the link between agricultural growth and intensification and land use. So on the left here is not normal Borlaug, but Norman Borlaug, who is called the father of the Green Revolution. He was a professor at Iowa State University in the United States and spent a lot of time developing new varieties of crops. He spent quite a bit of his time in Mexico, as well with the International Center for Maize and Wheat Breeding, or maize and wheat, based in Mexico, and going back and forth to Iowa, Mexico, and elsewhere in the world where there were major famines. So he did a lot of his work beginning in the 1950s and 1960s, and is credited for coming up with radically more productive varieties of the major staple crops, especially wheat and corn, and working with others to develop new varieties, radically more productive varieties of rice. And for that, he won the Nobel Prize for Peace in 1970, because at that time it was seen as that the next world wars would be fought over food. And that by radically increasing the amount of food available to humanity, it would take away this kind of this compulsion for conflict. With him here is M.S. Swaminathan, who is still with us. He's an elderly gentleman in India who I had the pleasure of working with. M.S. Swaminathan also was awarded an honorary doctorate from the University of Alberta several years ago. And he is seen as the father of the Green Revolution in India. What they did together, and we're working with crop scientists around the world, especially in the developing world, was to develop high-yielding dwarf varieties, so varieties of these three major crops that had a genetic code which kept them quite short. And by being short, they spent more of their photosynthetic effort developing the seeds, and there was a radical increase in yield of these major crops as a result of this breeding for dwarfism and higher productivity. At the same time, there were countries that were worried about the food security as a real national security issue, who were made investments to really make the most of these new varieties, investing especially in irrigation, and sometimes providing subsidies for other complementary inputs, such as fertilizers and pesticides. So the Green Revolution is seen as this kind of major leap forward in agriculture production, which had the consequence of really alleviating hunger in large parts of the developing world to a very great extent. So the question is, so when you have this type of technological change, like these new varieties plus these new technologies, would it reduce the area used for agriculture? So the Borlaug hypothesis was that it would. So if we could increase our yields radically, we could meet food needs on a smaller area of land. So it seemed sort of this obvious hypothesis was that for given food needs, if we're more productive, we intensify agriculture, then we can reduce our land use for agriculture. and therefore relieve that, allow that land to be used for alternative purposes like natural functions. So this is sort of seen as sparing land. Intensification that spares land allows that land to be used for nature or other purposes. Does that always hold? And the answer is no, but sometimes it does, and it varies by context. So I'm going to kind of go through this about the Borlaug hypothesis, the rebound effect, and Jevons paradox. So Jevons is pictured here as well. William Stanley Jevons, an economist who worked in the UK and wrote this book called The Question of Coal in 1865. And in 1865, his observation was that new technologies that made for more efficient use of coal were associated with increased use of coal. So why would that be? What's going on with that? If you have if your coal is much more efficient, why would you use more of it? Okay, so let's go into these two hypotheses, because we have the two hypotheses then are called the Borlaug hypothesis, Jevons paradox. So this paradox of increased production leading to increased coal use, increased efficiency leading to increased coal use. And what ties them together is something called the rebound effect. So here's the Borlaug hypothesis about land sparing, is that improvements in agricultural technology will enable farmers to produce more food from a given area of land, thereby enabling growth in food supply without increased land use. So this is the sharing land. So you can see these three trends over time. We've got this yield as a linear upward rise in yield. So that's output per unit of area, meaning that you can have lower cultivated area, and with this rise in production, especially if it's more rapid than the rise in population, then we can get a reduction in price over time. And to some extent, we saw that reduction in price from this Green Revolution period. But Jevons says, and other people who have then developed Jevons since 1865, the Jevons argument, talk about this rebound effect. So this is that if you have this greater output, so we have something which makes an input, like land, more productive, so we increase in yield, people will change their behavior. So they're not going to just keep saying, oh, how can I use that technology to produce a certain amount of output, which we call sometimes a satisficing behavior. People don't follow, if you think about back to our microeconomic principles of production, people we assume people don't follow just a satisficing behavior, that they follow a maximizing or optimizing behavior. They want to make most money. So if we have an input which is much more productive, then we're going to want to respond to that increased productivity of that input by using more of it compared to other inputs that we use. That's one thing, right? So we've got a substitution effect to the more productive input, and we're going to want to produce more output, right? Because we want to take advantage of the market and sell our stuff into that market. So we've got these two effects then. So the Borlaug effect is this yield effect, which I show as implying that the land area would reduce. But the rebound effect is that the area that we used increased, as well as the amount that we used increased. So the amount we're producing increases. So we've got these two things. On one hand, the yield effect reduces the area used. The rebound effect increases the area used. Both of these are consistent with economic theory, right? And they're offsetting, and sometimes the yield effect outweighs the rebound effect, but sometimes it works the other way around. Right? So sometimes if they balance each other out, you would see that you have a new technology, it makes, say, your land much more productive, and the area stays the same. Sometimes you'll see it reduce, sometimes you'll see it increase. So how can we predict why that would happen? And if we see it increase, then we say that we really have Jevons paradox, that the rebound effect has exceeded the yield, the pure yield effect. So this can help us think about when we see those different circumstances. And one thing it depends upon, though it's not the only thing, but one thing it depends upon is the relationship between price and quantity in the market. So this shows, let's think about the upper panel here, the relationship between price and quantity, and there's a demand function shown, which is quite flat. So there, if we could have a large increase in quantity, right? So if we have this much more productive inputs, we can use land more productively. What would we want to do? We can have a large increase in production with a small, relatively small decrease in price, right? So we're not being penalized much in terms of reduced price by producing more. So we'd want to produce more. So we would expect in that case a pretty large rebound effect. And we call that, when we have a large increase in quantity for a change in price, an elastic demand. So we have that type of demand, then we would expect a large rebound effect. On the other hand, if we have a small change in quantity, if a small change in quantity results in a large change in price, we'd call that an inelastic demand. In that case, we have a small rebound effect. So we don't want, our behavior isn't to radically increase the amount that we produce, because if we do, it really reduces the price, and our total revenue is price times quantity, right? So it might reduce our total revenues. We're going to be careful not to do that, in which case we expect a small rebound effect. So these circumstances hold in reality. The first place where we expect a pretty large rebound effect is a case of palm oil. And here's an article by Hammett in 2020 said, "Plant scientists can't ignore Jevons paradox anymore." And they use the case of palm oil, where because palm oil is a widely traded commodity, it competes on a global commodity market, you can increase the amount of palm oil quite a bit without reducing the price very much, because of the substitutability of all of these different oils. Even if you increase palm oil a fair amount, you are not going to have a crash in the price of palm oil. If that's the case, we expect a large rebound effect. On the other hand, we expect a small rebound effect, and we found, this Peltier article found a small rebound effect when, for the case of smallholder maize in Zambia, where most smallholder farmers there have small plots of land, and they're primarily trying to satisfy their own needs and the needs of a local market. They're not tied into big export markets. In that case, when they produce more, they expect on that local market, they would expect a large change in price. And therefore, they find, empirically, they actually find a small rebound effect. They find a small rebound effect means that the Borlaug hypothesis holds, right? In that we've increased intensification. We've got a technology which leads to intensification, and we've reduced at relatively little change, and we've got a yield effect which more than offsets the rebound effect. And that's kind of the opposite for the palm oil case. So this is an interesting area of kind of new analysis. There's getting to, just in the last few years, have we really had the data and the empirical methods to thoroughly test the Borlaug versus the Jevons, the Borlaug hypothesis versus the Jevons paradox, and really quantifying the two effects, right? The direct yield effect, which would reduce land use, and the rebound effect, which increases land use. We need to know more about these rebound effects and how they're shaped by market conditions, as I've just showed you, but also how they can be managed by things like regulations and property rights, because there are, if you can expect a large rebound effect, then there are other things that politicians and policymakers may do. Overall, then, this conventional intensification and the Borlaug hypothesis isn't a demon. It doesn't lead necessarily to large increases in production, though it can. And it's not the savior in terms of land use, because there are circumstances in which we have large rebound effects, and Jevons hypothesis, Jevons paradox holds. The other thing then is kind of think about, okay, is that enough for us to think about the type of agriculture that we need? Is this land use impact the main thing we think about? It's big, but also there are other negative effects. And we've talked about that last time of conventional agriculture on things like water quantity, water quality, greenhouse gas emissions. We need to pay attention to those when we think about the kind of the future of agriculture. So I'm going to stop that mini lecture here and stop sharing my slides.